Good afternoon, students. Today we are going to start the titration exercise. What do you mean by the titration? Titration is a volumetric analysis in which we calculate the concentration of the unknown solution by using known solution. Okay? In titration, you have given two type of the solution in exams. One solution concentration is known, and another solution concentration should be calculated. Okay? So you have given a questions for this exercise. You have given m by 20 FAS. You have given m by 20 FAS. फेरस अमोनियम सल्फेट का m by 20 सॉल्यूशंस आपको गिवन है. By using this solution, calculate the concentration of the KMnO4 in GPL. GPL means gram per liter. And for this exercise, you have given the following apparatus like urate, pipette, urate stand, funnel, filter paper, so many. Clear? And the reagent is the KMnO4 solution and ferrous ammonium sulfate. Dear students, you know in laboratory there are the two type of the reagents. One is the primary reagents and another is the secondary reagents. Primary reagents are those reagents which concentration does not affect with the time. Like they are not hygroscopic in nature. Their concentration remain always constant. Okay? Whenever. While the secondary reagents may be hygroscopic and their concentration may be changed with the time. Okay? For example, here two solutions are given. The transparent solution is known as the ferrous ammonium sulfate, and this is the primary reagent in laboratory. Its concentration does not change with the time. It is not a hygroscopic reagent. But in the case of the KMnO4 is a oxidizing reagent, you know, and this is the secondary reagent, and it is also hygroscopic in nature, and its concentration is changed with the time. So we calculate the concentration of the KMnO4 in GPL by using the ferrous ammonium sulfate. For this exercise, we have given a burette. This is the burette. In burette, there is a marking 0 ml to 50 ml. 0 ml to 50 ml. With the secondary reagent, which we want to calculate the concentration filled in the burette. Okay. Then first of all, we filled the burette by KMnO4 because I want to calculate the concentration of the KMnO4 in GPL by using funnel. Okay. Okay. When you will fill the burette, you should check the burette. It is open or closed. That it should be closed when you fill the burette. Then fill it. When you fill the burette, you should check that there is no bubble in burette. During the filling of the burette, you should check there should be not a bubble, not any bubbles in burette. Okay. When I filled the burette, then we observe that the mark going upon the 0. Then the excess solution in burette is removed by the stopper. Okay. One thing is learning here. There are the two types of the solution. One is the colored solution and another is the colorless solution. Okay. When you fill the colored solution in burette pipette, then you should make the lower meniscus. And when you fill the colorless solution, then you should check upper meniscus. Upper meniscus. What do you mean by the upper meniscus, lower meniscus? Huh? When any type of solution filled in capillary and due to a surface tension, a curve is formed of the solution. Okay, you understand? When any type of solution, a liquid solution filled in a capillary tube, just like a capillary tube, large capillary tube. This is also capillary tube. Okay, then due to the surface tension, a curve is formed. Okay, and there is a mark in burette and pipette. Okay, when colored solution, the meniscus should be exist in this way, and when the colorless solution, the meniscus should be in this way, and this is the lower meniscus, and this is the upper meniscus. This is the lower meniscus and this is the upper meniscus. Okay, लोअर मेनिस्कस कौन से केस में? कलर्ड. और ये कौन से केस में? कलरलेस. Okay, so here the solution is colored or colorless? Colored. Then we check which type of meniscus? Lower meniscus. So I set the lower meniscus. देखिए Okay, this is the lower meniscus because the solution is colored of KMO4. Okay, now if the solution is split, please clean as soon as possible because it is always affected our accuracy. Okay, now this is the conical flask. Okay, in this conical flask I have taken the primary reagent ferroammonium sulfate by the help of pipette. Okay, all of you can see that there is a mark in pipette, a circle marks you can see. Yes. Are yes or no? Yes sir. Okay, I suck the ferroammonium sulfate by mouth, sucking the ferroammonium sulfate by mouth. How can this possible? देखिए एक बार dip this pipette in the ferroammonium sulfate and suck. देखिए इस समय मेनिस्कस दिख रहा है आप लोगों सबको. You can see the meniscus and the meniscus जो है अपर मेनिस्कस किस तरीके से जो मेनिस्कस बन रहा है उसका पार्ट जो है लाइन को टच कर रहा है. यू कैन सी. ओके, दिस इज द 20 ml ऑफ द ferroammonium sulfate and I have taken in conical flask. Okay, put it here in where is stand. Now I am going to start titration. Okay, how much amount of KMnO4 is required to 20 ml of the ferroammonium sulfate, and that amount we can calculate the amount concentration of the KMnO4 in GPL. Okay, now I am going to start. Slowly I am shaking it. At the end point just slightly pink color is appear. Okay, 1 or 2 drops add more in amount. Okay, just the reading is the 10.5. Okay, this is the slightly pink color. ठीक है, slightly pink color.